Welcome to this particular module, and here we will look at one more type of oscillator, which is your LC oscillators. Alright. So, it is also called tank oscillators, and we have seen until now RC oscillator or phase shift oscillator. We have also seen the Wien bridge oscillator. Now, it is time for us to understand what are L and C oscillators. L when I say it is inductor, C when I say it is capacitor. So, there are two reactance reactive components in the RC oscillator, and of course, to sustain the oscillation we have to use a amplifier, So, when we talk about an amplifier, then what we see, we can change the gain of the amplifier. So, here to make it a little bit different than our previous experimental modules, right, that we have seen, this time we will see how we can use a multisim to implement this RC to implement this LC oscillators, and we will see that how we can design the LC oscillators in multisim and how we can see the change in oscillation without actually using the DC power supply or without using the oscilloscope. Alright, this is kind of simulation, right, it is a simulation. So, but the point is that if you do not have this equipment with you, you can also do you can use multisim at home and try to design this circuit and see the output, right. So, it will be a good exercise, and we will when the time will come, I will ask Sitaram to come here and show us how the multisim can be used, and when he is using the multisim, I will also help and tell you how the frequency is generated and how the oscillations are generated in that particular tool. Alright. So, coming back to the LC oscillators, the one thing that you need to understand is the Lenz law. It is LENZ, Z is nothing but Z, we can say Z, we can say Z. So, Lenz law you have to understand, and then you have to understand how capacitor charges and capacitor discharges. Alright. So, that is extremely basic, and I expect that as an undergrad or as an master students or as an PhD student, you already know how the capacitor is working or how the inductor is working. Alright. If you do not know, please study and learn how the capacitor and inductor works, then you will understand what is Lenz law. Alright. So, to understand the LC oscillators, we will see two kind of LC oscillators. In this particular module, we will see the Hartley oscillator, and in the next module we will see the Colpitts oscillator. So, what is Hartley oscillator? For understanding Hartley oscillator, first we should understand that the Hartley and Colpitts oscillator, they both work on the principle of using L and C, that is charging and discharging of capacitor and inductor happens, and because of which the oscillations will start generating, and when it charging and discharging of capacitor and the inductor happens, when capacitor charges and inductor discharges, when inductor charges and capacitor discharges, then the loss of energy, and that is why at the output of the Hartley oscillator or Colpitts oscillator or LC oscillator in general, the waveforms will start damping, which will go down, and that is why to sustain the oscillation, we have to use an amplifier. Alright, this we already have discussed in the theory. Now, let us see quickly what we have discussed, and then we will implement this on multisim. Alright. So, if you see the screen, what we are looking at? We are looking at a Hartley oscillator. And it is nothing but consists of a parallel LC resonant tank circuit whose feedback is achieved by way of inductive divider. So, this is a representative circuit where you can see that the feedback circuit is given by Z1, Z2, Z3. In case of Hartley oscillator, we will find that Z1 and Z2 will be L and Z3 will be C, or you can say Z1 and Z3 and Z1 is L and Z2 is C. So, that means that we have two inductors and one capacitor. If I actually draw a circuit, you can see here there is inductor 1, inductor 2, capacitor, and then this feedback resistor can be used to change the gain, Now, Depending on the impedances, the LC oscillators can be classified. If Z1 and Z2 are inductors and Z3 is capacitor, the circuit forms an Hartley oscillator, which is shown here in figure number 15, alright. Advantage of using op amp in designing RC oscillator is to control over gain using resistance values. We already know there is op amp, if we use, then we can have a change in the gain with the help of the resistor values. So, ideally the gain of the circuit is set equal to or slightly greater than L1 by L2. Okay. This you have to remember that the ideally the gain of the this particular oscillator is set equal to or slightly greater than L1 by L2, and we have seen that frequency formula is nothing but f equals to 1 by 2 pi, f equals to 1 by 2 pi, right, under root of LC, Here we have LT we are giving, which is equivalent to L1 plus L2, which is equivalent to your L1 plus L2. Alright. So, if I want to actually design this oscillator, how can I design this oscillator, right? And let us see a question, let us see an example that if I want to design oscillator, how can I design? So, the problem statement is that a Hartley oscillator circuit has two individual inductors 0.1, 0.5 millihenry and are designed to resonate in parallel with a variable capacitor that can be adjusted between 100 picofarad and 500 picofarad, means we can have C equals to 100 picofarad minimum and we have maximum 500 picofarad. We have inductors 0.5 millihenry, right. Determine upper and lower frequencies of oscillations and also the Hartley oscillator bandwidth. So, we have to find F H, we have to find F minimum or F L, F minimum or lower, so F L, and we have to find the bandwidth. These three things we have to find, alright. Now, we already know what is formula for frequency for the Hartley oscillator. The formula of the frequency is F equals to 1 upon 2 pi under root of LC. What is L? LT equals to L1 plus L2, we have already seen in the previous slide. So, we have to add 0.5 plus 0.5, which will be your 1 millihenry. Now, we have value of LT. Now, we have to consider the capacitor C, right. So, for 100 picofarad I have Fh equals to 503 kilohertz, right. For 100 picofarad if I use upper frequency, then I have Fh equals to, I have to consider this value. We have seen this example previously also, right, why we are using capacitor of lower value when we were to measure upper frequency. When we measure lower frequency, I will use a capacitor of higher value, this maximum value, which is my 500 picofarad. So, for the Fh I will have 503 kilohertz, for Fl I will find it about 225 kilohertz. Now, if I know what is Fh, if I know what is Fl, my bandwidth is nothing but Fh minus Fl, my bandwidth is nothing but Fh minus Fl. So, 503 kilohertz minus 225 kilohertz will give me 278 kilohertz. So, an easy problem in front of you, an easy example that is given, the solution is super simple. So, you should be able to do it at home, right, without any problem, Okay. So, this is the case when we are using an Hartley oscillator with inductors value given, capacitors value given, right, and we have to find the Fh, we have to find Fh, we have to find Fl, and we have to find bandwidth. But what if we have a different kind of problem? Then in this particular case, which is your experiment, right, how we can design this particular oscillator, how can design with this particular oscillator. Again you can see the same circuit is there, and here we can connect the circuit as shown in figure. The same circuit we can design in multisim, like I said, right. We have to observe the output signal at pin number 6, this is pin number 6, and then measure the frequency of oscillation and match the theoretical value, alright, match the frequency and measure with the theoretical value. So, let us see how we can use the multisim to find out the Hartley oscillator, Hartley oscillator. Alright. So, I will ask Sitaram to show us on multisim how we can design the RC oscillator. So, if we see here, we have the schematic diagram, right, which is similar to what you have seen in the slide, and here we can see again we have two inductors, R1, L1 and L2. We can see on the screen there are two inductors L1 and L2, right, and we have one capacitor which is C1. So, the values are 50 Henry, 50 microhenry, 100 microhenry, and the capacitor is 100 microfarad. So, if we have these values and if I have R2 equals to 1 kilo ohm in this particular condition, right, what kind of waveforms I can generate, So, you will see here the output voltage, you will see here the oscillations in at the output of the Hartley oscillator, right, and if you change the it is really similar to oscilloscope. You can change the frequency, you can change the time per division, right, by using the knob, and what right now we are doing, we are increasing the time per division, right. So, you can see this where we can decrease the time per division. So, we can see this, right. Also we can see simultaneously both the screens where we can see the change in the output voltage. You can see the change in the output voltage at the green terminal, the green point, right, and correspondingly we can also see the change in output voltage in the plot, right. So, this is a super easy way of using the multisim at your home. It is a free version, so just try it and try to design the circuit, try to design all the circuits in fact, and see whether you can find similar kind of waveforms. At the same time you can always go to the laboratory and use the facility in the laboratory to see whether you can have the similar kind of waveforms or not, alright. So, we will stop here for this particular module, and this is how you can quickly design the Hartley oscillator using the multisim, alright, But what if I have capacitors, what if I have two capacitors and I have one inductor? If I have two capacitors and if I have one inductor, then it becomes my Colpitts oscillator, So, when I have a Colpitts oscillator, then what kind of changes I will get in my output, or how can I design my Colpitts oscillator. So, that Colpitts oscillator we will see in the next module. It is again the part of LC oscillator, but here the reactance is we are using two capacitors and we are using one inductor, alright. In the Hartley that we have seen recently right now is we have used two inductors and we have seen one capacitor. So, we will see in the next module how we can design the Colpitts oscillator. Till then you try to load the multisim, it is free version. So, you can just design the circuit that you look in the YouTube or the uploaded version of this NPTEL videos, and try to see whether you can find the similar kind of waveforms which we have seen, which we have shown you on this particular screen, alright. Till then you read once again, right, ask me any question if you have any difficulty, right, try by yourself first and then only you ask, okay. So, I will see you in the next class and we will see how you can design a Colpitts oscillator with the help of again a multisim. So, now you are able to understand that we are not only able to design the circuit by using the breadboard and the equipment, we can also do a simulation at home using this particular tool, right. So, one step up, like I said, that as we move towards the experiment part and we go towards the end of the experiment parts, your complexity of designing the circuit will slightly increase, right. We started from very basic things which is offset, right, and we reached to the thing that you are able to design an oscillator, alright. So, I will see you in the next class with an Colpitts oscillator. Till then you take care, and I will see you in the next class. Bye.